Next episode.
All right, welcome everybody to the new edition of Next Episode. Today we're going to talk about circular solutions with Luca Botti. Luca, welcome.
Nice to meet you.
Yes.
Nice to meet you again,
Yes.
Mark.
Yeah. So Luca, you have a PhD in chemistry. You have been working with in the Boston consultancy group with a lot of experience in strategy, and now for about 2 years working in NextChem on circular solutions. Since 2024. So I think a circular solution, I think the thing that comes to my mind to start with is, well, a circular solution that's probably waste, but I imagine there's a lot more to it. So where do we start this conversation? If you would run into an old classmate in a bar, say, hey, what are you doing? I'm working in circular solution. Say, what's that? How would you explain this?
That's a good question. Always tough, because it's a very complex environment. But what I would say is, what we do, is closing the loop.
Okay.
It's as simple as it is. So when we come to waste, it means bringing waste. So something that in the past was thinking as linear and to be disposed of, taking waste and bring it back to a product that needs to re-enter the value chain. So what we do every day is obviously by commercializing our solution, we talk with stakeholders that are at the end of the value chain, so waste management, and at the beginning of the value chain, so chemical producer, product producer, and so on. So what I would say, I tackle it from closing the loop, and obviously to me it's about the material. So from material to material, we have different kind of solution and different kind of approach, starting from MSW, then going to plastic, then going to water, then going to precious metal recycling.
Okay. So then waste. If I think about waste, I think there are two main images that pop in my head. One is like my own household waste that I put in the bin and then it gets pushed somewhere, probably to an incinerator, or I think in some European countries to landfill. And the other one is more related to, I saw a video recently from the ocean cleanup where they've taken big garbage pack, ocean garbage pack, I think it's called, but also cleaning rivers and doing stuff like that. But those two will be very polluted.
Okay.
It's not a clean feedstock from a chemical process. How do you start there? Because you have this big pile of that's waste. I think of junk. There's a lot of stuff in there. How do you get to using that again?
Let's start from what we have today. No?
Okay.
Obviously, ocean is a big problem, and that's, let's say, another bottleneck we can talk about in a few. But talking about general waste, that obviously has a lot of contamination, is an extremely heterogeneous material. How do we recycle it? How do we dispose it? Today, what we are doing are basically two things. Landfill, so basically, we put it there, we let it sit there, and it doesn't make emission, obviously, but is creating an environmental issue. Okay. Or incineration, which obviously diminishes the problem related to environmental issue of landfilling, because we don't have contaminant that gets in the soil, etc. We are producing electricity because we burn the waste, we take the electricity that the waste gives back to us, but we are producing a lot of emission, a lot of CO2. Our idea was, how do we make that CO2 valuable again? Because that CO2 is a problem, creating greenhouse gases emission, but it's an opportunity, because for us, CO2 contains carbon, and carbons make up all the things that we touch and do.
There's a lot of feedstock there.
There's a lot of feedstock, exactly. So in NextChem, what we are doing, we are offering a solution that we call NEXTCircular. Okay, it's a gasification solution, and the beauty of it is that we work with a limited amount of oxygen, high temperature to really break down the molecule in the waste to a small building block that is called syngas, carbon monoxide and hydrogen. From that building block, we can do new type of chemical. We can do methanol. We can do SAF. We can combine our
sustainable aviation fuel.
Sustainable aviation fuel, exactly. So we can move ship. We can move planes, and with methanol as well, we can make things. We can make chemistry. So we combine this solution, NEXTCircular, with other downstream solution. For example, our methanol solution from gas contact, and we can create an overall process that is 100% recycling and can produce a sustainable material. So this is where I see the solution and the opportunity that we can bring in MSW,
Okay, and then this is, let's say, starting waste, but there's also in waste, there's stuff that's not so valuable. There's stuff that's very easy to recycle, maybe not easy, but reasonably okay to recycle. But there will also be metals in there. Is that also, I think gasifying that sounds a bit weird to me. Is that a separate approach, or how do you?
I mean, when we come to metals in general waste, let's say in our solution, we kind of create a slag of it, So obviously we want a waste that is majorly carbon. We don't take construction waste. We don't take electronical equipment.
You're selective to start with.
Exactly.
Okay.
But it's a super flexible approach, and then obviously there is always some contaminant, there is always some metals and so on, and then we have a little stream of that dense concentrated metals that can go either in further recycling if there is value in it, but it actually is quite a stable and inert component that we can use as a construction filling, as a material. So with that solution, we also address that problem. But then also we have dedicated solution for precious metal recycling that are in electrical equipments.
Okay.
And that's another topic, but it's another stream. It's another stream of waste.
So it's being selective to start with, then posting it as well, recovering as much. You say value a lot, which is interesting because I think 20 years ago, I think waste was waste and indeed it was incinerated, but you really view this as a source, as a feed, as something that can deliver value. But it has its challenges due to the diversity of the composition of the waste. Then the assumption is that it would be a lot easier to just recycle, for instance, plastics that start from a industrial player or that have more purity.
Absolutely.
That's then, do you use the same gasification solution for that, or do you have something else in mind to create value from that?
I mean, obviously gasification, as I was saying, is for general waste. Okay. Before getting to the general waste, separate collection is key. Okay, so in our household we separate plastic, glass, paper, and so on. As well in the industry, it's what they are already doing, no? And so for those cleaner stream, we need to take a different approach. Why? Well, because with gasification, we are extremely flexible, but we go back a lot in the value chain, in the production chain.
Yeah.
We go to the single molecule. Instead, if we have pure plastic, we don't need to go back to the molecule, we can take a simpler approach, just taking the plastic and treat it to have or either recycled plastic or either, an oil that it's that can go easier back in the value chain. So there we take a dual approach. If the plastic, for example, is quite pure, it's all the post-industrial is good, or even the post-consumer that is of good quality, we take it and we can, as an NEXTChem, we can offer a solution that is an NEXTEplast for mechanical recycling, Otherwise, pyrolysis, what we call pyrolysis, can take all the stream of plastic that are contaminated. When we call contaminated, that are full of other plastic or that are dirty. And in NEXTChem, we can, we recently went through the acquisition of Balestra, big news over there for the last few months. And with Buschem Tech, we are offering an innovative pyrolysis solution that can take those plastic and create an oil that can go back in the either fuel industry, but what we aim is the chemical industry.
Okay. And how does that process work? The pyrolysis? How do you get from plastic to oil?
That's quite simple. Simple to say, not to do. But we take that plastic. We kind of melt it and we put it in this reactor. Okay. Here we work with a very, very low amount of oxygen. So before in gasification, I was saying that we were in deficit of oxygen.
Yeah.
Instead, in this reactor, we are basically no oxygen. We heated the plastic to high temperature, above 400, 500 degrees, depending on what we do. And there we are, the plastic they have long chain. No, we start to break those chain. What is solid plastic, we break it into a oil that is similar to the oil that now is processed in the chemical industry. So that oil, we will go back to cracker to produce ethylene, to produce polyolefin, for example.
Okay. And then you also said, briefly mentioned mechanical recycling. So that's pure. Let's say a high purity of plastic, but not 100% pure, because then you would not have to recycle anything. So how do you make sure you increase the composition of those type of plastic? How does mechanical upcycling or recycling work?
That's a great question, and that's where I see the great opportunity and the great value that we bring in NEXTChem as well. Because with the NEXTEplast, it's not only about mechanical recycling; is what we call compounding B2B.
Okay.
So obviously, with our technology, we can take the plastic, shred it, washing it, separate all the different flakes. Because sometimes the waste is not homogeneous, so we can select the plastic that we like.
And how do you select that? Because there's probably no people doing that flake by flake.
No.
So how does that? Is that something?
No. We have a IR detector, infrared detector that basically can read the frequencies of resonance of each polymer.
Okay.
And they say, oh, this is polyolefin, this is polystyrene, and they can, do different baskets.
Okay. Also does color then?
Also coloring.
Okay.
Also coloring. That's even easier. We can separate all the different colors. But that's exactly the key point. You touch. That's the easy part to me. That's nothing new. Nothing new. We can do all these different baskets. Try to imagine. We have the waste, and the first part of the plant, we make all the different baskets. Black polyolefin, red polyolefin, polypropylene, polyethylene.
Yep.
We prepare the ingredients. Yes. I like to say, no. But the real value to me is recognizing that this plastic have an history, have a past. Okay, we have an asset here in Milan, close to Milan, in Brescia, that do this every day. So what we do, we understand that plastic before has the previous life. A bumper, a bottle the plastic in there was additivated. It's not 100% pure, probably it's 99, but they have different additives that make it perfect for that application.
Yes.
Polypropylene for bumper has few additives that make it perfect for the bumper. Polypropylene for bottles has few additives that make it perfect for the bottle.
Yeah, but different additives. Yeah.
So the real opportunity here is being able to have all these ingredients, analyze these ingredients, and recognize that they have a different life before.
Okay.
And then, considering the past, you adapt your recipe on what you want to make. So why we call it compounding B2B, business to business, because we know what is coming from the application of our waste. It was a bumper, it was a bottle, and we know what our clients want. They want to make bumpers, they want to make bottles. So considering that we know the past and we know the future of that plastic, we can change the additives as we want to make it perfect for that application.
Okay, so it sounds like in terms of a plastic soup, but it sounds like a plastic chef. You pick ingredients
we
and
change the seasoning. We change the seasoning depending on the season. You get nicer tomato or little bit of flavoring tomato, and then we can change the seasoning to make it perfect.
Yeah. Okay, so it's an interesting comparison to think about plastics in that way, because then you can sort of cook with that as well. So that's really nice. Okay, and then the amount of different plastics, especially if you include color, is basically indefinite, right? So there are 1 million different colors of all kinds of plastic. So I'm assuming it would be a lot easier if all bottles are transparent or whatever they have, or if you have a limited amount of plastics you can use, or even a limited amount of colors you could use to enable recycling a lot better. Is that something that's on the table of regulators, or how do regulators help, let's say, the plastic recycling business?
I mean, no, that's a very good question. I think plastic recycler is a big issue for regulators. Let me say, first of all, let's make it clear. Recycling is a big issue because plastic is a great product. Okay, it's durable, it's light, it's cheap. Plastic contributed as much to our economy probably as fertilizer, no?
Yeah.
I mean, it's incredible to think about the jump that society made thanks to plastic. But thanks to these properties, obviously, it becomes an issue environmentally wise. Yeah. So regulators are taking a serious approach to this. And they are tackling in two ways. One is regulating the use.
Okay.
It's not only about limiting, because it cannot be limited in my opinion, but it's about not to, let's say, excessively use plastic in application that maybe can be used something different. So that's why single-use plastic are really, an issue to tackle.
Yep.
Okay. But also regulators, as you were saying, how we can really make sure that something is easier to recycle. And you were mentioning the color. Well, regulators are incentivizing now a more responsible product design. So easier to recycle, easier to disassemble, no composite plastic, no multi-layer plastic. Those are a small action, but then when we come to waste management, it makes a lot of difference.
Yeah, can imagine.
But the real difference to me is what they're doing in terms of recycling target and recycled mandate. Recycling target, obviously now regulators in Europe, they're saying each country need to recycle this percentage of plastic. Okay.
Yeah. Of plastic or of waste?
They do it in general, and they have different target for different type of waste. Okay.
So it's basically on just to understand, if you are a plastic producer, X amount of your feedstock needs to be from a recycled source. Is that?
That's a recycled content.
Okay.
There is the recycling. So obviously it's you put a target on the country. You say you need Europe need to recycle 40% of plastic. No, so it's about imposing on the country an action to improve the waste management. Okay, because otherwise they will pay a fee. They will pay taxation. Okay, the so-called plastic tax. But then, that's where it comes. The second point that you were mentioning, the recycle mandate. Okay, if we just do an amazing waste management sorting, we need to create demand for it. And that's why, as you said, they start to say, if you make a new product, you have to have X amount of recycled plastic. Okay, depending to product, to industry, because it's different if you make a bottle, if you make a car. But they are incentivizing demand for recycled plastic, and that's what is really driving up prices as well of recycled plastic. What is creating demand, what is creating a business case for recycler. Is the implementation is tough, we know.
But then it sounds like you're, especially if you have the the gasification as well. Let's say the purer the feedstock, the easier it is. Makes a lot of sense. And then, of course, if you have a pure feedstock, you can just select the right flakes, melt it, make something new. If it's more dirty, more mixed, then you need to segregate, wash a bit more, but you can still reuse it. And at some point you will get to, let's say, whatever is left over. And there you would say, well, we used to incinerate or landfill that, but that we can gasify and we can make something new out of this.
Absolutely.
How does that link back to the original, let's say, virgin plastic? Because if you have this syngas, would you just build, like you mentioned, gas contact and methanol in the beginning, make a plastic factory next to a waste management company and then close the loop? Is that happening somewhere already?
I mean, you are thinking about integrated approach.
Yes.
I would say not with gasification, because gasification, the beauty of gasification that can go to chemical industry and to fuel industry, no? So there is no much need of that strong integration, okay? There's an integration of competencies because, as I like to say, you start with a waste management plant and you end up with a chemical plant, but not integration of location. But what is we are doing, for example, is another stream of plastic. We are working on an amazing technology that is called NEXTEPSODE, PMMA, with a JV that we did in MAIRE Mono.
Joint venture, yes.
We are building a plant, right, in Italy for it, for taking the PMMA and depolymerizing to MMA.
What is PMMA? Is a specific kind of plastic, or?
Yeah, you're right. PMMA is plexiglass.
Yeah.
The brand is plexiglass, obviously, and it's basically those kind of transparent plastic that is used in car lights, is used also in countertops, sometimes in the kitchen. We don't know it, but it's MMA, and also in plastic glass. It's a great plastic that is almost a technical plastic. Needs to have great performances. Okay. The cost is actually quite high. Probably is 2-3 times the cost of polyolefin. So it's a added value plastic, I would say. We can recycle it. We can break it, to polymer, to monomer.
Yeah.
Okay. So why we don't go in mechanical? Because the property of that plastic needs to be so pure, so fine, that we need to think about something different. Mechanical recycling is something, as I was saying, with seasoning and additives. Here we need to work really in extreme purity. So that's why we do chemical recycling. In that plant, in that technology, we wanted to integrate it with industrial plants. So we really believe that in that kind of technology, we need to integrate the recycling facility, the production facility, to have the best performance.
But then what's the, speaking of ingredients, what's the magic sauce? What's the technology that makes this work? Because you say that mechanical recycling doesn't work. It needs to be more pure.
Yeah.
How do you do that?
We take the PMMA, and then we have a very special reactor that use molten metal. Molten metal really distribute heat amazingly, and it's up the PMMA in just the right way to break down the chain and release the monomer. And the monomer we can then purify it and have it super pure. But you see, I mean, that's why it's so difficult. So say at the beginning, from different type of feedstock, you have a different type of industrial approach.
Yeah.
So you really need to be flexible and know the industry, really know and understand the industry that you are facing with.
Sounds like plastic is here to stay, but it's going to be a lot more circular than it used to be when we were kids.
It needs to. Absolutely.
But I think the message that you give is quite, in a sense, is quite hopeful. The technology is there.
The technology is there. What I see now as the big step is also what we are working every day. Is the consumer, is the end user. So obviously in the industries, the chemical producer have been, let me pass the term, spoiled, by virgin plastic, because it's easy. You have never contamination, you know exactly the products, and they are used to make their products with virgin plastic. Working with recycled plastic, with recycled monomer, it requires you to change approach. It requires you to have a bit more complexity, in your feedstock, because inherently we have some contaminants, and you need to face that complexity as we are doing in MAIRE Plus, as I was saying before, with the seasoning.
Yeah.
You really need to take that proactive approach. So the technology is there. We really need to help product user to use in the right way that recycled plastic, but the plastic is here to stay. But
is there something a consumer should do, or have maybe a change in mindset, or is there any consumer power here that can leverage circularity?
I mean, as I saying, everything helps, and to me is about really a dual approach. Obviously consumer helps a lot. Any choice of taking a recycled product versus a recycled packaging, for example, versus
And how do I see if it's recycled?
I mean, usually there is a good advertisement.
Okay.
Because but you see, but that's why, I mean, for example, we see different brands now that goes into recycled plastic. They claim that they really market their recycled content because they know that customer somehow are becoming aware of this, and we want to drive the money the right way. But I think also, I don't want to leave all the responsibility to consumer, right?
No.
Because
But I can imagine it if I buy, or maybe with food it might be more challenging, but if there are plenty of use cases where it doesn't matter that much if my bottle is the same color every time. I'm just thinking about maybe I have this image in mind now of the cucumbers in store, have this plastic wrapping around them to preserve the cucumbers longer. I don't care if that's transparent or if it's purple or whatever.
No.
I just care about my cucumber. So if we would educate consumers, hey guys, this is recycled and therefore the color variation can differ a bit, I will be okay with that. Maybe not everybody, but is that something that you see would be a path forward, or you say, Mark, that doesn't make sense, we can make it happen without any color variations?
No, I think you actually touch a great point, and I tell you what, I'm a bit even more extreme than this. I want to make this example. I was in a regulation committee. They were talking about recycling mandate, and there was a very important, let's say, player there of bottles, and actually food packaging. And they were complaining that they were not using recycled plastic because the bottle were becoming a bit more brownish. It was not a problem of quality, it was not a problem of food content. It's because the bottle was a bit more brownish.
Yeah.
And actually, they actually sell a black liquid, so I'll let you think about that. But that's the thing. I'm like, we really care if our bottle is just a bit more brownish. We don't.
If you tell me this is more brown because it's recycled, I would probably buy it sooner than if it's a virgin whatever color.
And actually, now I'm quite pleased that it's been 5 years since I had that meeting. And today I see that brownish bottle in the supermarket. So for me, that means change is happening. They understood we don't care. We don't care. We want to see recycled product. We want to see circularity happening. But as I was saying, it's not only something that I want to leave only on consumer. It needs to be a regulator. Plastic is an opportunity. It's a great power, and from power comes responsibility. So we need to take it as a society.
Be the future you want to see.
Exactly.
Yeah. Luca, thank you so much for this insight in the world of plastic. I've learned a lot, and I hope our listeners have as well. Thank you so much. Thanks for our listeners for tuning in to the next episode, and I hope to see you in the next edition. Thank you so much.
See you soon. Ciao, Mark.
Next episode.